Good morning, students. In this lecture, we will cover the Ramjet engine, that is the last of the air breathing engines of the syllabus, and very briefly the rocket propulsion engines. So let us go to the next topics that are going to be covered over here. The Ramjet engine. We have heard about the BrahMos missiles, the Akash missile used in the Indian Armed Forces. These missiles are based on the Ramjet engine, for information. Now the feature. Ramjet is a form of air-breathing jet engine that uses the engine's forward motion to compress the incoming air without any compression, right? Because ramjets cannot produce thrust at zero airspeed, they cannot move an aircraft from a standstill. So a ramjet powered vehicle therefore requires an assisted takeoff to accelerate it to a speed where it begins to produce thrust. Ramjets work mainly efficiently at very high supersonic speeds around Mach 3, that is 2300 mile per hour or equivalent to 3700 km per hour. This type of engine can operate up to Mach 6, that is 7400 km per hour. They are particularly useful in applications requiring a small and simple mechanism for high speed use, such as missiles. Now here the engines, as discussed, requires neither a compression nor a turbine. A sufficient pressure rise is obtained by decelerating the high speed incoming air in the diffuser, right? That is the diffuser part. Here the incoming air is decelerated. Incoming air is already at very high speed, and this effect is known as ram effect. That is, the incoming air at high speed is being rammed against a barrier. There is a barrier inside it and it is rammed. For the ramjet to operate, the aircraft must already be in flight at a sustainably great speed. The combustion products existing the combustor are expanded through a nozzle to produce the thrust. This is the nozzle part, right? So the basic characteristics are: it is simple engine and should be adaptable for mass production at low cost. It is independent of fuel technology and a wide range of liquid and solid fuels can be used. Its fuel consumption is comparatively very large for its application in aircraft propulsion or in missiles at low or at moderate speed. Its fuel consumption decreases with flight speed and approaches reasonable values when the flight Mach number is between 2 to 5, and therefore it is suitable for propelling supersonic missiles. Due to its high thrust at high operational speed, it is widely used in high-speed military aircraft and missiles, that is air-to-surface missiles, air-to-air missiles, etc. Subsonic ramjets are used in target weapons in conjunction with turbojets or rockets for getting the starting torque. The advantages are very simple. They does not possess any moving part. It is very cheap to produce and requires almost no maintenance. Due to the fact that turbine is not used to drive the mechanical compressor, the maximum temperature which can be allowed in ramjet is very high, about 2000 degrees Celsius as compared to 900 degrees Celsius in turbojets. This allows a greater thrust to be obtained by burning fuel at air-fuel ratio at about 13:1, which gives higher temperature. This specific fuel consumption is better than other gas turbine power plants at high speed and high altitudes. But there are some disadvantages also. Since the compression of air is obtained by virtue of its speed relative to the engine, the takeoff thrust is zero and it is not possible to start a ramjet without an external launching device. The engine heavily relies on the diffuser and it is very difficult to design a diffuser which will give very good pressure recovery over a wide range speed. Due to high speed, the combustion chamber requires flame holder to stabilize the combustion. At very high temperature, at about 2000 degrees Celsius, dissociation and products of combustion occurs which will reduce the efficiency of the plant if not recovered in the nozzle during expansion. Now let us go to the rocket propulsion. That is the last part. Chemical rockets are so far the most widely used rocket. They depend upon the burning of fuel inside the combustion chamber and expanding it through the nozzle to obtain thrust. The important characteristics of chemical rockets is that the propulsive energy is obtained from the fuel and a carried oxidant. The propellant may be made of solid and liquid. So based on that, chemical rockets are classified into solid propellant rockets where fuel and oxidizers are combined as a solid, right? And in liquid propellant rockets, the fuel and oxidizer are stored separately, then later combined and ignited. Now, the desirable characteristics of the propellants. Now, as discussed, the ability to produce high chamber temperature in general, low molecular weight of products of combustion, high density to reduce the physical dimension of overall missile by allowing a large propellant weight is given, easy storage and handling, no chemical reaction within the system, readily ignitable and availability. So, this is the very simple view of the solid propellant rocket engine. The working is like this. The figure shows the schematic diagram of solid propellant rocket. It consists of a combustion chamber, an expansion nozzle and an igniter. The peculiar characteristics of this type of rocket is that the entire propellant is contained in the combustion chamber, which has its oxidant within the fuel itself. Therefore, the normal duration of combustion is in such a motor is relatively very short, less than a minute basically. Both fuel and oxidizer are homogeneously mixed within the solid propellant grain. The figure indicates the major components of the propellant grain, the casing, the nozzle and the igniter. Igniter is not shown here. After ignition, the propellant burns more or less evenly and at a steady state. Thus, the name cigarette burning often been used. So, after the burning causes rapid composition of the heat release and the heat is conducted back to the propellant and thus the process is self-sustaining. Such a process is called the burning by deflagration. So as discussed, so these are the features. The features of the solid propellant are the burning by deflagration, factors affecting the burning rate, the flow of gas through the system, duration of thrust production, and there is no provision of active cooling system. They are mainly used in rocket assisted takeoff of aircraft, large missile boosters, and they are main power plant for the multiplicity of missiles like the AAM, that is the air to air missile, surface to surface missile, surface to air missile, that is SAM, that is, and an AASM, that is air to surface missile. In solid propulsion rockets also they are used in the initial stage during the liftoff of the satellites. The solid propellant, that is the booster rockets, are used, as can be seen. In liquid propellant rockets, the liquid oxidizer and the fuel is carried separately in fuel chambers. They are greater potential and you will be discussed very briefly. Right? The main parts are an oxidizer tank, a fuel tank. This is the oxidizer tank and the fuel tank, and the oxidizer and the fuel by the control valve is used in the rocket motor, and the rocket motor is the heart of the rocket engine. Through a injection plate they are inserted in the combustion chamber. Combustion takes place and the high temperature, high pressure gas is expanded in the nozzle and extremely high value of thrust is obtained. Right? The basic component of the motor comprises of an injection plate. This is the injection plate through which the droplets of mist of fuel droplets and the oxidizer is sprayed into the combustion chamber. This is the B is the combustion chamber and N is the discharge nozzle, as discussed. At present, there are two general systems of transporting the propellants from their storage tanks to the rocket motors. They are gas detection system and the pump pressurization system. These topics have not been discussed in this lecture. For greater details, the reference books can be referred, which are mentioned over here. Two books mainly utilized to prepare the lectures throughout. They are the Engineering Thermodynamics by P. K. and Gas Turbines by V. Ganeshan. These are the some YouTube links mentioned for your. These contain some animations which will be very useful if you are interested. They are mentioned. So this is it. This completes the lectures on the chapter gas turbine and jet propulsion. Thank you.